Hello everyone, I am going to explain question number 3rd from exercise 7.6 from class 12th. And in question number 3rd, we are going to solve the D part. And in the question, we have to verify the Lagrange's mean value theorem for the given function. So here the given function is fx is equal to 1 upon 4x minus 1, and where x belongs between the closed interval 1 to 4. So students, we are going to verify the Lagrange's mean value theorem. So for Lagrange's mean value theorem, there are two conditions. First condition is the function should be continuous in the closed interval, and the second condition is function should be differentiable in the open interval. So first we will see whether the function is satisfying these two conditions or not. If function is satisfying, then we will move to the conclusion of Lagrange's mean value theorem. So we will start from the first condition, that is continuity. So first I wrote here the function is fx is equal to 1 upon 4x minus 1. So we have to check whether this function is continuous for all the number which belongs from 1 to 4. So for check the continuity, if we will check by actual process, is going to be very lengthy. So the short method is we only have to check whether the function is finite and has the unique value for each different values of x which belongs between 1 to 4 or not. Defined means for any value of x which belongs between 1 to 4, it should not be infinity. If infinity will come, means the function is not defined at that particular value of x. So students will start, because it's a closed interval, so we'll start to think that if we substitute here 1, then 1, 2, 3, 1.2, 1.3 like this. So I think that for any value of x, it's not going to be infinity. And since it's not going to be infinity, means it is defined for each x belongs from 1 to 4. So first thing is clear. Now second thing, it's unique or not. Unique means for every value of x, it should be different. So students, if you will put different values of x from this closed interval to this given function, we will get different corresponding answers for the values of x. That's why the function is unique for each x belongs from 1 to 4. So to prove continuity, these two things are sufficient. First, it should be finite. Second thing, it should be unique for each value of x which belongs in the closed intervals. Now since we went through both the points and we concluded already, so we can write here fx is continuous in the interval 1 to 4. Now we'll move to the second condition of Lagrange's mean value theorem, that is differentiability. So we have to differentiate it. So I wrote it in the power form so that I can differentiate it easily. To avoid the fraction formula, I converted it in the form of x to the power n. And students, x to the power n differentiation is n x n minus 1. So I wrote here n, then x n minus 1 formula. Then according to the chain rule, we have to differentiate this bracket also. So when we differentiate 4x minus 1, 4 is the coefficient, so it will come in front, and x differentiation is this one. And this minus 1's differentiation is 0. I am repeating again. We first assume it as x to the power n, and x to the power n differentiation is n x n minus 1. So what is n here? Minus 1. That's why minus 1 minus 1. Then chain rule we have to apply. So we will differentiate this 4x minus 1 again. So when we differentiate 4x differentiation is 4 multiplied by 1, because x differentiation is 1. And then 1 is constant, so 1's differentiation is 0. So we will simplify it. So it's minus 2. Since power is minus 2, so when it will shift to the denominator, power is going to be positive. And here only 4, and 4 and minus 1 multiplied, we obtain minus 4. Now we have to check that this function is differentiable for every value which belongs from 1 to 4. So students, we only have to check whether it is defined, f dash x is defined for each x belongs between 1 to 4. So if we orally substitute the values of x which belongs from 1 to 4 here, it is defined because it's not going to be infinity for any value. That's why fx is differentiable in the open interval 1 to 4. So both values of Lagrange's mean value theorem is satisfied. That's why there must exist a point c belongs between the open interval 1 to 4, where f dash c is equal to function's value at upper limit minus function's value at lower limit upon 4 minus 1. So now we are going to calculate f dash c, f4 and f1. So I calculated here f4, that is 1 upon 15, then f1, that is 1 upon 3, and f dash x we already differentiated earlier, so in that only just replace it by f dash c. Instead of x, just write down c. Now we obtain all the values, so replace it in equation 1 again. That is your equation 1 I wrote again here. Now in this just replace f dash c, f4 and f1 value. That will give you this line. Now from here we need to find out the value of c. So it's a quadratic equation. So I have opened it by a minus b whole square formula, that is a square plus b square minus 2ab, and here I took the LCM, and then LCM is simple fraction simplification, just do, you will obtain this step. Then just minus 4 and minus 4 get cancelled and cross multiplied, and this 45 just shift here, so we will obtain minus 44 divided by 4, that will give you this line. Now this is a quadratic equation which we have to simplify by any method. Here I obtained the quadratic formula. So if a equation is ax square, here students plus will come, plus bx plus c equal to 0. In that situation x is minus b plus minus b square minus 4ac upon 2a. So in this you just substitute the values from here. So that will give you c, and so we obtained these calculations. These calculations might be very easy for you, because simply we had opted the 10th class concept to solve the quadratic equation. And here I obtained b square minus 4ac as 180, and since I want to take the square root, so I split it into the multiple of complete square number and any other number. So I obtained 36 multiplied by 5. From 36, square root of 36 is 6, that's why 6 came here. Separate them and then cancel it and take LCM again, you will get this step. Now here root 5 is 2.2 approx, and when we multiply we will get here 6.6. So here plus minus both are possible, but if we take the plus sign in between, that will give us the 1.4 which belongs in the open interval. That's why we will not take the negative value, that is 1 minus 1. That we will move to the positive one only, because then only the value of c will belongs in the open interval 1 to 4. So for c is equal to 1.4 which belongs in the open interval 1, 4. The given function is satisfying the condition f dash c is equal to f4 minus f1 upon 4 minus 1. So hence Lagrange's mean value theorem is verified. I hope this question is clear to you, and here I firstly I explain the calculations, because you know already quadratic, how to solve the quadratic equation by quadratic formula. So calculation just do by your own self, and finally you should get c equal to 1.4 approximately, which belongs between the 1 to 4. So students, if you have any problem you can write in comment, so that we can solve your doubts, and if you have any suggestions that also you can mention. Thank you.